Hello everyone, welcome to Leetcode Solver, and today we are going to solve 20th problem in 30-day lead coding challenge, and the problem name is first unique number. Let me open the problem. You have a queue of integers. You need to retrieve the first unique integers in the queue. Okay, in a queue I have to retrieve first unique. Implement a first unique class. Okay, first unique will accept int number array and initialize the object with numbers in the queue. Okay, returns the value of the first unique integer of the queue and return -1 if there is no such integer in a queue which is unique. Which is unique means here not repeated multiple times. Insert value to the queue. So we have three methods provided into the class. First one is first unique, which is basically constructor to initialize the object with the numbers in the queue, and so FirstUnique will return the first unique integers in the queue FirstUnique, and returns -1 if there is no such integers. Okay, and we can also add up the new value to the queue. That's interesting. So if we don't have to add, then like we have to show the first unique, then what we can do, we can just put everything in a lookup table and just with the frequency of their occurrence, and just iterate from the beginning to the last and find the one which have frequency 1. That would be the first unique number. And if we have to add value, then this will also work, but we have to maintain the what was the last first unique integer index, and from that index we will just iterate over. If we do not maintain that index, then we have to go from the beginning again and again and do the same thing. So because if we put this index, then it will be linear time complexity. Even if we have to add, let's see how many queries will be there. Is there any constant? Well, there is a constant. The initial number size is 10 to the power 5, and every numbers can be up to 10 to the power 8, which is the integer range which can hold in integer. And the value, okay, 10 to the power 8 value that we're gonna add also, and there will be only 50,000. Okay, at most 50,000 calls to make so unique, so first unique and add. So overall, if we think about the length of the array, that could be at most 10 to the power 5 plus 50,000 if we put the every 8 operations value to the queue, then that size will be that bigger. And so first unique, for so first unique, we can just iterate from the beginning to from beginning to last, beginning to the end, till the end, and we can also maintain what was the index of the first unique previously. Well, we can do this. First unique will be provided as a vector nums. Okay, then what I'm thinking is that in first unique, I will just put everything in a lookup table, a hash map, every numbers along with their frequency, and in the constructor itself, first unique constructor, I will maintain that hash map, and also I will find the one, the index of the, well, there are two ways that we can find the first unique values. One is like whenever we are adding value, then we will just iterate over and find the index of the uh, first unique, and whenever we call this first unique, we will just return the given value in the given index. Or if Yeah, if it is out of range, then we'll return -1. So that is one way that we can do. Another way that we can do is whenever we call first unique, then we'll just iterate and find the first unique one from the previous one. Well, I think we can maintain, like whenever we called add, then we can just iterate and find the index of the first unique, and whenever we call show first unique, we'll just depending upon the whether it is out of range or not, we will just return that first unique value. So let's maintain some extra variables like that we have to maintain, which is first of all we have to maintain vector q basically. So if we maintain vector, it will be easier to access. So let's maintain vector for q. Is there any better term? Q of integers. Okay, say q, and we can also have map, which is basically frequency of. So let's maintain a hash map to get it in constant time complexity on ORTRET unordered map, which is hash map, or say frequency. We maintain the frequency of the number, and we also maintain first unique index. Well, whenever we are calling this constructor, we will find that first unique index as well. Let's say 0. Before that, let's put entry to the. We can just copy our q will be equals to nums. We copy the vector, and let's put every values in the q to the frequency. We can also easily do it by int x in nums to the frequency of x plus plus, and let's find first unique index. If first we could not find first unique index, then we will simply return the size of the nums. So or we can put this to another method, as it will be useful next time as well. Let's put it over here. Find first unique index and yeah, say first unique index is 0 initially, and we're gonna find this. So we'll iterate over the q size, and if we see that frequency of starting from first unique index. This is also interesting. Starting from previous first unique index, we will iterate over queue size, and if we found that frequency of q of I is 1, so we'll simply just calculate that and break. So we will find the first unique index will be equals to I and break. Otherwise, if we do not find any, then we will just put a size of which is equal to the size of the queue. First unique index will be equal to queue dot size. Well, this is a void method, and we will call this void method. From here we will find first unique index, so that it will be useful whenever we want to show the first unique index. If q dot first unique index if is equals to q dot size, so that means we don't have anything to show. In that case, -1. Otherwise, we will return q of first unique index. Okay, now what happens if we add? If we add, we will do the same thing, like we will push q dot push value, and we also update frequency of value will be increased, and we will again call this method to find the first unique index. Well, sounds good to me. Let's run the code. Compilation error. 28 use of undeclared identifier first unique index. Q dot push. Okay, push back. Where it is, by the way? 32. Null -1, null -1, null -1, everything -1. So what is the test case? First unique will be null. Why null? First unique, show first unique. Okay, this is initialization. So first unique is -1. Okay, wait, 2 or 2, 3, 5 initialized. 2, 3, and 5 initialized. Q is nums and first unique index is 0, and we update the frequency iterating over nums. So first unique index, we will start from first unique index previously, what was that, and we will iterate over the queue, and if we find that frequency of particular is 1, then we find the first unique index. Okay, So yeah, there is a mistake, and we are breaking. Mm, we can just return 2 2 3 minus 1. Looks good to me. Let's submit. Well, it is accepted. That's nice. Let's see statistic. 560 millisecond and 122.7 megabyte. Well, we may think about optimizing memory. So the time complexity of the solution is big of the num size and query size, and space complexity would be the same, num and queue size. Thank you so much for watching this video, and if you have any queries or any suggestion or any alternative solution, please feel free to comment. Have a nice day.